All right, let's talk about the first derivative test. Now, all of this is going to be a lot more concrete once we start doing some curve sketching and we start looking at some examples. So don't memorize all these words you see in front of you. Understand conceptually what the derivative tells you, and this is all really easy. I absolutely would not memorize these words here. But the first one says, if your derivative goes from positive to negative at some x value, c, then you've got yourself a local maximum there. If it goes from negative to positive, then you've got a minimum. And if it doesn't change signs, then you don't have a maximum or a minimum. You probably have what's called a saddle point. What does all this mean? The derivative is positive when your graph is going up, when it's increasing. It's negative when the graph is decreasing. So let's look at this region right here. In this region, in all of these values right here, for all of these x values, the derivative would be positive. Positive derivative means the graph is going uphill. Over here, look at the graph, it's going downhill. We're always going from left to right, always from left to right. You're riding along, say you're in a little car here. And here's you. And you're going this direction. Here you would be going uphill. That's a positive derivative. All my tangent lines have positive slopes. Right here at the top, your derivative is 0 because the tangent line is horizontal. And over here, your car would be going downhill. Well, if you go from uphill to downhill, the only way that can happen is if you've reached some local maximum. So these values here, these are the critical points. These are all the places where the derivative equaled 0 or did not exist. Critical points are where the derivative is 0 or undefined. The derivative is positive when you're going up, negative when you're going down. If you go from up to down, you've got yourself right here a local max. When you're going the other way, so I'm going downhill here, uphill here, that spot, that critical point is a local min. This guy right here, I'm going uphill, I level off just for an instant. So the derivative is 0 right there. I've got a horizontal tangent line at that one location, but then I keep going uphill. That's not a maximum because I'm not higher than this spot. It's not a minimum because I'm not lower than this spot. It's neither. Like, you don't have to know this word, but we call that a saddle point. Okay. And this is called the first derivative test. So somebody hands you a function and says, find all the local maxes and mins for me. You find all your critical points because Fermat's theorem says all local maxes and mins occur at critical points. So you find all your critical values. And then you do a sign chart for the derivative. You figure out where the derivative is positive and negative. And from that, if you go from positive to negative, you've got a max. If you go from negative to positive, you've got a min. And this, again, will make more sense once we draw out some of these sign charts. I'm going to take this graph that we're looking at here, and I want to do something different. I want to sketch the derivative. So I'm not graphing the original function, I'm graphing the derivative. At all of these critical points, the derivative, well, at these critical points, the derivative was 0. So right there at B, the derivative is 0. Same at C. And at D. At this point, at A, the derivative was undefined. So here, I'm going to have some kind of infinite, it looks like, derivative. Okay, in this region, in this entire region back here, the derivative is positive and it's getting bigger and bigger and bigger. It's getting steeper and steeper. So I've got some kind of vertical asymptote here, and all those slopes are positive and getting more and more positive. In this entire region, my derivative is negative. I'm going downhill, and back here, I was like negative infinity. So my derivative is going to come from negative infinity and go to 0. Negative. All of the derivative values are negative. In this region, from B to C, I'm going uphill. Uphill means positive derivative. Not increasing derivative, positive. So I'm at 0 here, I'm at 0 here. I'm going to be positive in this entire region. I'm going to write down these positives and negatives. Increasing, positive derivative. Decreasing, negative derivative. Positive derivative, positive derivative, negative derivative. So I'm in this region. I'm looking from B to C. I'm looking right here. I'm going to be positive the whole time, but I have to hit 0 at both points. The only way that can happen is if it goes something like this. So you look at all those values, they're all positive. Remember, this is positive up here above the x-axis. This is all positive, and down here is all negative. When we say positive and negative, I mean the y values. Okay, from this region here, from C to D, my derivative is positive the whole time because I'm going uphill. And it has to come down and hit that point there because I know it's 0 there. And then on this entire region, bigger than D, my derivative is negative down here. So this is what the graph of the derivative would look like. We're going to play this game quite a bit where we're going to look at the formula, use the derivative to sketch the original, and we're going to play the game where we take the sketch of the original and use that to sketch out the derivative. And then we're even going to go one step further and sketch the second derivative. So a classic example of this might be a position function. Then what we would be sketching here might be the velocity function, and his derivative would be an acceleration function. And we're going to do a whole bunch of examples. Okay, that's a good place to stop in this one.